N to N. This is the domain. Domain and codomain are natural number set. Natural number set means n equal to 1, 2, 3, 4, just like that. This is the natural number set. It is defined as if n is odd, n plus 1 by 2, if n is even, n by 2. Okay, so this is a domain, natural number set. It is codomain. It is also natural number set. 1, 2, 3, 4, just like that. 1, 2, 3, 4, just like that. Okay, here observe that. Let n equal to 1. 1 means what? Odd number. N is odd number. So f of 1 is equal to, go to odd case, n is odd. F of n equal to n plus 1. N plus 1 by 2. That is equal to 2 by 2. That is equals to 1. Next, what is f of 2? 2 means n is equal to 2. 2 means even number. Even case, n by 2. That is equal to n by 2. That is equal to 1. So, 1 is mapped with 1. 2 is also mapped with 1. 1 is mapped with 1. 2 is also mapped with 1. Therefore, different elements are not mapped with different elements. They are mapped with one element. Therefore, f of 1 is equal to f of 2 for 1 not equals to 2. So therefore, means what? Even if the elements are different, images are same. Therefore, f is not 1 function. F is not 1 function. Next, on to function. On to. First, I will take a odd case. On to function. Let n be odd case. Odd means that is f of n is defined as, in this case, n plus 1 by 2. So, as usually according to procedure, let y is equal to f of x, comma y belongs to codomain n, capital N. Here n is codomain. Okay, that implies y is equal to, what is f of x? F of n equal to n plus 1 by 2. Of course, n belongs to natural number. F of x means x plus 1 by 2. According to procedure, obtain x value. So, x equal to 2y minus 1. Now, I am asking one question. What is that? This value total 2y minus 1, is it belongs to, again, natural number? Natural number means it is domain. For all y belongs to codomain. Means take y means from here. It is x values, set of x, it is a set of y values. I am asking that you can take any 1, 2, 3. Instead of y, put y equal to 1, y equal to 2, y equal to 3, y equal to 4, y equal to 5, and so on, just like that. Here, are you getting again natural number? It is the question. Let us verify. What is this question? 2y minus 1. First, put y equal to 1. Y equal to 1. 2 into 1. 2 minus 1. That is equal to 1. Okay, it is also belongs to natural number. Next, y equal to 2. Then, this number 2 2 is 4. 4 minus 1, 3. It is also belongs to natural number. Next, y is equal to 3. 2 3 is 6. 6 minus 1, 5. It is also belongs to natural number. Thus, for all y belongs to natural number, we are getting again natural number here. So, it is correct. Therefore, f is onto function, in the case of n is odd. Next, case 2. N is even case. N is even means here f of n equal to n by 2. Of course, n belongs to natural number. Same procedure. Let y equal to f of x. Y belongs to n. N means here codomain. That implies y equal to fx. Fx means x by 2. So that implies x equal to y. So for all y belongs to natural number means it is codomain. It is again natural number means it is domain. Very clearly means put y equal to 1, 2, 3, 4 and so on, just like that. Again we are getting natural number. So therefore for all y belongs to natural number n, x is also belongs to natural number. So therefore for all y belongs to natural number, there exists a small x, it is also belongs to natural number means a domain, so that y is equal to f of x. Therefore f is onto function. So therefore in both cases f is onto function. Therefore f is means f from n to n is onto function, but not one function. It is only onto function. Remember. Over. Here, next question. F of x equal to x minus 2 divided by x minus 3, rational function. For example, if x equal to 3, then denominator becomes 0. Then function should not be defined. That's why he said the domain of this function, domain is equal to any real number except 3 for defining f of x. Next, codomain or range. Codomain is equal to its name is capital A. Codomain, its name is capital B. Here capital R minus the set of 1. What does it mean? This is the function. This is the function defined as x minus 2 by x minus 3. So you can put any real number except 3, but the output or range will be any real number except 1. Indirectly it is not equals to 1. The resultant value should not be equals to 1. So if it is equal to 1, then what will happen? Means that x minus, he is saying that x minus 2 by total x minus 3 should not be equals to 1. He is saying like that. Sir, if x equal to 1, then what will happen? 1 minute. So x minus 2 cross multiplication, then x minus 3. So therefore it is meaningless. That's why he said the outcome is any real number except 1. So we are not getting the resultant value 1. We are getting any real number except 1. It is the complete meaning of the given function. Okay. Next. So this is f of x. Right. First is f one function. So first we verify for one function. So as usually let x1 comma x2 belongs to domain. Domain means A, capital A, means except 3. x1 comma x2 are any real numbers but except 3. It is the complete meaning. And A means what? Domain. A means what? Domain. And let f of x1 is equal to f of x2. So that implies f of x1. F of x1 means x1 minus 2 by x1 minus 3, that is equal to x2 minus 2 by x2 minus 3. So by cross multiplication, x1 minus 2 into x2 minus 3, that is equal to x1 minus 3 into x2 minus 2. So that implies multiplication x1 x2 minus 3 x1 minus 2 x2 plus 6, that is equal to x1 x2 x1 x2 minus 2 x1 minus 3 x2 plus 6. So x1 x2 cancelled, 6 cancelled. So on balancing this equation, we are getting x1 is equal to x2. Therefore, for all x1 comma x2 that is belongs to domain, and f of x1 is equal to f of x2, that implies x1 is equal to x2. Therefore f is a one function. Next, on to function. You come here. Heading on to function. For on to function. Okay. As usually, the procedure is let y is equal to f of x, comma y is what? Y is from codomain, means capital B. Capital B is what? Capital B means any real number except 1. Okay. So that is imply y equal to f of x minus 2 by x minus 3. What is the procedure? Obtain x from that equation. So that implies cross multiplication y into x minus 3 equal to x minus 2. So implies that x into y minus 3y equal to x minus 2. So that implies xy minus x equal to 3y minus 2. So that implies x into y minus 1 equal to 3y minus 2. So that implies x equal to 3y minus 2 divided by y minus 1. I'm telling that this value y is what? Y belongs to y. Here y belongs to b, capital B. Capital B means any real number except 1. I'm telling that this value not at all equals to 3 for all y belongs to capital B. You can verify for these infinite values. For example, I got this value is 3, sir. Let us verify. 3y minus 2 cross multiplication 3y minus 3. The 3y will be cancelled. So meaningless statement. Understand? That's why I am telling that it should not be equals to 3. Should not be equals to 3 means what? X belongs to any real number except 3. R minus 3 means what? Capital A. So that is capital A for all y belongs to capital B. Therefore, for all y belongs to capital B, there exists x belongs to capital A, so that y is equal to f of x. Hence, y is equal to f of x. F of x, or simply f is onto function. Therefore, f is one function and onto function. Therefore, f is 1 and onto function. That implies f is bijective function. F is bijective function, hence the problem. F from A to B is a function and G from B to C. So F comma G be the two functions so that the codomain of F is the same as domain of second function G. We are taking like that. Then the composition of F and G is denoted by G circle F. Here observe the order. Composition of F and G is G circle F. The composition means circle is defined as A to C. How? Here A to B it is F, B to C it is G. Now in this direction A to C, G to F, that is what? G circle F is from A to capital C. This is called composition of F and G. Its domain is capital A and codomain is capital C, and defined as G circle F of something A is equal to G of F of A for all A belongs to here adjacently the letter F is there. So in F, what is the domain? Capital A. So A small a belongs to capital A. Means what? Composition. Notation circle, small circle. Circle means nothing but bracket. This is called composition of F and Z. Okay, next similarly the composition of G and F. 1 minute. Before that we have to define G capital X to capital Y and F Y to Z. Already I said here, for the composition of F and G, the codomain of first function is same as domain of second function. That's why we took Y same for G and F is F circle G. F circle G means first capital X to capital Y. X to Y it is G. Y to Z it is F. Already I said this cyclic order. So X to Z and F to G means F circle G is X to Z and defined as F circle Z of something X is equal to F of circle means single bracket, only one bracket, Z of X for all X belongs to Z. X belongs to capital X. G domain capital X. Okay, this is the simple definition of composition of F and G and composition of G and F. So, and always F circle G not at all equals to G circle F. 1 minute. If F circle is defined, there is no any restriction for G circle F. Means even if F circle G is defined, there is no rules and regulations for defining G circle F. May be defined G circle F or may not be defined G circle F. Similarly, if G circle F is defined, then maybe F circle G defined may not be F circle G defined. So anyhow, F circle G not at all equals to G circle F. We are seeing this same result in next coming examples. Okay. One small application. Let F from the set of 1, 3, 4 means let it be capital A domain and capital B the set of 1 to 5, G capital B the set of 1 to 5 and C set of 1, 3. Observe that the codomain of F is same as domain of G. That's why G circle F is defined. Okay, for which two methods are there. In first method I will explain the complete meaning. In second method I will explain the shortcut to find either F circle G or G circle F. Let us consider example 1. First example 1. Here capital A is equal to 1, 3, 4. Capital B is equal to the set of 1 to 5 and capital C is equal to 1 comma the set of 1 comma 3. Therefore F from A to B and G is from B to C are two functions. So this is the complete explanation or complete meaning. So F here, F is equal to ordered pair of 1, 2, 3, 5, 4, 1 means what? F of 1 equal to 2, F of 1 equal to 2, F of 3 equal to 5, F of 3 equal to 5. Next F of 4 equals to 1, F of 4 equals to 1. Right. Next here G of 1 equal to 3. G of 1 equal to 3. Next tell me G of 2 equal to 3. G of 2 equal to 3. Next G of 5 equal to 1. G of 5 equals to 1. Next what is the question? Find G circle F. Find G circle F. So G circle F. So what is the last letter? F. Go to F. What is its domain? 1, 3, 4. So find G circle F of 1, G circle F of 3, G circle F of 4. Just like that. So last letter F. So we must take the domain of F there. What is the domain of F? 1, 3, 4. 1, 3, 4. So that is equal to procedure. G circle means just keeping one bracket, taking one bracket, writing one bracket. Circle means one bracket. So F of 1 we can write like that. So G of F of 1 is what? 2. Next G of 2 is what? 3. So answer is 3. Next similarly it is G of F of 3 that is equal to G of F of 3 is what? 5. But G of 5 is what? 1. Next G of F of 4. F of 4. So G of F of 4. F of 4 1. But G of 1 is what? 3. So therefore we can write like that. G circle F is equal to the set of 1 is mapped with 3. 1, 3. Next 3, 1. 3, 1. Next 4, 3. 4, 3. Just like that. This is the complete procedure for finding G circle F, or we can find F circle G if it is defined. Okay, 1 minute. Second method. Here you see F. 1 is mapped with 2. We are talking about F. 1 is mapped with 2. 3 is mapped with 5. 4 is mapped with 1. Okay. This is all about F. Next, go to G. Go to G. Here, it is G. In G, 2 is mapped with which element? 2 is mapped with 3. So, it is 3. Next, in G, 5 is mapped with 1. 5 is mapped with 1. In G, 1 is mapped with 3. 1 is mapped with 3. You come here. What I said, this is the direction, means just like one cyclic direction. So A to C, G, F. A, C, G, F. A, C, G, F. Just like that. Just like that. Just like that. Just like that. A to C means G circle F. G circle F is A to C. Just like that. So 1, 3, G, F. Therefore, G circle F equal to 1, 3, 3, 1, 4, 3. 4, 3, 4, 3. So, all are G circle F. It is about G circle F. So, we got the same answer. 1, 3, 3, 1, 4, 3. This is the shortcut. Okay, next. Second example. Second example. What is f of x? Given f of x equal to 8x cubed and g of x equal to x to the power of 1 by 3. First question. Find G circle F. First. G circle F means f of x. Take f of x. That is equal to G circle means one bracket. F of x we can write like that. F of x according to this definition or this definition like that. That is equal to G of you come here. What is f of x? 8x cubed. 8x cubed. 8x cubed. Okay. That is equal to G. Go to G. G is this one. X to the power of 1 by 3. 1 minute. 1 by 3 same. Whole power 1 by 3 same. Whole power 1 by 3 same. Here, instead of x, just you write 8x cubed. 8x cubed. This is the substitution. G of 8x cubed. Once again, G. G means what? X power 1 by 3. Okay. Power, coefficients, signs will be the same. So, I wrote the same. 1 by 3 power. Next. Instead of x, right? All these things. 8x cubed. So, that is equal to 8 to the power of, means we can write it as 2x whole cubed. Simply 2x whole cubed. Again, whole to the power of 1 by 3. So, 3 cancel. It remains only 2x. Next, F circle Z of x. So, F of Z of x, that is equal to F of, what is G of x? G of x is defined as x to the power of 1 by 3. X to the power of 1 by 3. F is what? F is 8x cubed. 1 minute. F of x is 8x cubed. It is given. So F means 8 something cubed. Instead of x, 8x cubed. Instead of x, we write all those things. 8 means x power 1 by 3. Just like that. So that is equal to 8 into 3 cancel. It remains only x. So therefore, G circle f of x is equal to 2x and f circle g of x is equal to 8x. So sometimes both f circle g and g circle f may be defined. Okay, but f circle g not at all equals to g circle f. Over.